Evaluate the definite integral from -1 to 2 of x over e to the 6 minus 2x squared dx. So in order to do this, the first thing that I need to do is change this into work out the indefinite integral first, and then I'll take care of the definite part. So starting with the indefinite integral, we'll just call this x over e to the 6 minus 2x squared dx. Now, probably going to need the use of u-Substitution here, but I have another issue going on with this denominator. I don't particularly have a quotient rule for integration, and so we can't just throw this into a quotient rule to evaluate it. It's always going to be best if you have something like this. If you can rewrite this with a negative exponent, you're much better off. So that would be to the -6 plus 2x squared, or what's nicer is just rearranging those terms and calling it 2x squared minus 6. That's going to help out. Now, the next thing is u-Substitution. Picking something for u is the trickiest thing in u-Substitution, but as long as it's an inner function and its derivative looks like some other part of the problem, that's what we are interested in. Most of the time with exponentials, it's just the exponent. Here, that works out pretty well. I would need to divide this constant 4 over to make it match up just right. So 1/4 du is x dx. So this will become 1/4 e to the 2x squared minus 6 is going to be just e to the u, and then x dx, those get changed into 1/4 du. Okay, so at this point we have a couple of things that we could do. We could continue and change everything back to the variable u when we do our indefinite integral, or we can change everything back to the variable x and then evaluate, or we can change everything into u and make our lives easier. I am going to do that. So what I am going to do is take my function u, plug in the endpoints of integration. When I do that, I get, let's see, 2 times -1 squared minus 6. So that's 1, 2, so -4. This will be 2 times 2 squared minus 6, so that's 8 minus 6, which is 2. So the new endpoints of integration are going to be -4 and 2. The nice thing about this is I don't need to go back to the original variable here. So this would just be 1/4 of, since e to the u is its own antiderivative, it's just going to be 1/4 of e to the u evaluated from -4 to 2, which is 1/4 of e squared minus e to the -4th. And we could get an approximation for that, but the exact answers are always much more preferred. So let's just leave it as is, and that is our answer.